Hello everyone, welcome to Aryan Tutorials. So now it is about lecture 8, which is on I'm going to explain about moment of force. So about the moment of force, what is the definition of the moment of force? Means here the moment of force is a turning effect produced by the force on a body on which it is acting. So that means whenever the force acts on a body, it causes the rotation on the body. Okay, so that rotational movement is called as here the moment of the force. So here consider this is as a body, a solid body on which a force is acting in a vertical direction. So the effect of this force causes the rotational motion, that is the movement of the body with respect to any point here. If this point is pivoted here, so automatically whenever the force is applied, the movement of the body takes place in clockwise direction. So the force P is acting, so the clockwise rotation may takes place may take place whenever the force is acting like this on a body. So that turning effect is called as a moment of a force. So we can find the quantity of the moment of force by taking the product of force and perpendicular distance from the given point to the line of action of the force. It means here how to find out the magnitude of the moment of the force whenever the force is acting on a body which is causing a turning of the body. So that means here the magnitude of the moment of force can be determined by taking the product of the force and the distance from any point which is perpendicular to the line of action of the force. That means here moment of force is equal to force P into perpendicular distance from any point to the line of action of the force. So here graphically we can represent. So now I want to show a simple diagram. So let us assume on a bar OM, a force is acting like this at a point M in a downward direction which causes the clockwise moment. Okay, so assume it is as a P which is acting at a point M. So now, and it is acting at a distance of R from O. So that means here the distance between OM is given as R and the force is acting at a point M. So due to this force, what is the moment of the force taking place here? We can find out by the by the formula, that is product of force and the perpendicular distance from the point. Any point means here we consider O because the distance we have considered O. So whatever the R we have mentioned here, this R is the perpendicular distance to the line of action of the force only. So automatically we can find out the moment of force P is equal to as a product. So here I will show you force into perpendicular distance from O to the line of action of the force. That means here the force is P and the perpendicular distance from the point O to the line of action is R. Okay, so here finally we can write it as P into R. So this is the way of finding the magnitude of the moment of force whenever the force acts on a body. So which causes the turning effect, that is the rotational motion, that is the moment of the body due to a particular force acting on a body. So like this we can find out the magnitude of moment of force. So this condition we face in any engineering problems whenever the force acts on a body. So as well as finding the resultant forces, we need to find out the moment of the force also whenever a force acts on any body. So for that we have to know the moment of force. So next thing, we are going for next example. In the previous one we have assumed the force is acting perpendicular to the bar we have considered, but here let if the force is acting inclined to the body as shown in figure below. So that means here, sorry, so in this condition for the same OM bar which is of length R, for this the force is acting at an inclination. So at an inclination of theta, the force is acting to a bar OM at a point M here. So in this condition, how to find out the magnitude of moment of the force? Means here the formula is same. The moment of force is equal to product of force P into the perpendicular distance from the point O to the line of action of the force. That means here we need to find out the perpendicular distance. Here the OM is not the perpendicular distance from the point O because it is inclined at an angle of theta. So that means for finding the perpendicular distance to the line of action of the force from the point O, we need to extend the line of action of the force up to certain distance. Then we have to draw the perpendicular line from point O here. So draw the perpendicular line from point O. So this is the perpendicular line. We have drawn point we have drawn from point O. So if we know this distance, assume point as A. Sorry, I am representing the angles here. So this one is theta, means automatically this opposite angle also becomes theta. So when I have said already, this is line is perpendicular to the line of action of the force P. So if it is 90 degrees, automatically the remaining angle becomes 90 minus theta only. So I'm assuming the end point as A. So here we need to find out the OA distance. Okay, if you find the OA distance, we can know that the distance, the perpendicular distance from the point O to the line of action of the force, we can know that by finding the OA. So for that, assume OAM as a right angle triangle here. So OAM here, this right angle triangle I have separately taken. So in this we need to find out the OA. If we find out the OA, we can find out the moment of the force, because it is a product of P into perpendicular distance from the point O. So OA we need to find out. So for that, same, represent the angles. Angle is 90 minus theta, that is the angle between OA and OM. So that is 90 minus theta. Here we need to find out OA. So in this condition, take cos 90 minus theta. Cos 90 minus theta is equal to adjacent by hypotenuse. So adjacent is OA and the hypotenuse is OM. So here we need to find out adjacent distance OA, that becomes the perpendicular distance here. So the OA is equal to, we can write it as OM cos 90 minus theta. So the OM means, again we know that is the length of the bar we have considered OM. So OM becomes R, and cos 90 minus theta becomes sine. Okay. So the R sine theta will get as a distance OA, that is the perpendicular distance that we have to find out. So we determine the perpendicular distance, then we have to find out the moment of force here. So the moment of force becomes the product of force P into perpendicular distance r sin theta. Here we got the perpendicular distance OA as r sin theta. So finally, the product of force into perpendicular distance from a point O to the line of action of the force here. So finally, we have determined the moment of force P. So like this, we can find out whenever the force or load is acting at a particular inclination to a body. So this is the way, and in another way also we can find out. So if the force is acting same case, so for the same case we can also find out the moment of force by resolving the force into two components. So here the condition is same, the force is acting at certain inclination to the body, that is the bar OM we have considered. So here we can resolve the force also into two components whenever the force acts at an angle, at a particular angle theta or whatever it may be. So resolving means horizontal and vertical direction we need to resolve into two components. So the horizontal component becomes r cos theta, sorry, p cos theta, we have considered the force, and vertical component becomes p sin theta. So here, by considering this one, p sin theta is the vertical force and the r is the distance, perpendicular distance to the line of action of the p sin theta from a point O. So by considering these two elements, directly we can find out the moment of the force. So here moment of the force P becomes P sin theta into R. Okay, that is the vertical component of the force into perpendicular distance from the O to the line of action of P sin theta force. So like this also we can find out the moment of the force, that is force into perpendicular distance R. So this is another way of finding the moment of the force when the force is acting at a particular inclination to a body. Okay. So next we understood that how to find out the moment of force and what is moment of force. We have to know the units of the units for the moment of the force also. So what are the dimensional units we can have? Means here the formula is moment of force is equal to force into distance. Generally we know that the unit of force is Newton and the distance is meter. So here we'll get Newton into meter. So in symbolic we can represent it as Newton meter. Okay. So these are the units for the moment of force. And next is types of moment of force. So the types of moment of force, we are having two types. One is clockwise movement and another one is anti-clockwise movement, based upon the direction of the force acting on a body, so which is trying to rotate through a particular direction. So here take an example AB bar on which a force P is acting. So here with respect to A, this AB bar can rotate in a clockwise direction only, in which the hands of the clock moves. Okay, so this one is called as clockwise movement, which causes the rotation or movement in a clockwise direction. So that is clockwise movement. and second one is we can have anti-clockwise. So according to the direction of the force acting, the force is acting upward, vertically upward to the bar AB, so which causes the moment of the bar AB with respect to A in anti-clockwise direction. Okay na? So opposite to the direction of the motion of the hands of the clock. So based upon that we can call it as anti-clockwise movement. Okay, these are the small main types of the movement of the forces. Okay, so up to now that is enough. So in this lecture we have discussed about the what is moment of force and how to find out the moment of force in two particular conditions, and what are the units for moment of force, and what are the types of moment of force. And in next lecture we are going to discuss what is the law of moment of force, and next what is the Varignon's principle stating. So all these two things we'll discuss, and at the same time we discuss the problems on the moment of force also. So I hope you understand my explanation. So if you don't understand, please feel free to give a comment to my video, so that I will try to improve my explanation, and feel free to give any suggestions to improve my explanation. And thanks for watching my video. Thank you all.